So if we type these into our calculator, there's a pattern here that you might notice. You might already know where we're headed with this. But when you do 4 to the 1/2 power, you get 2. Right? When you do 9 to the 1/2 power, you get 3. When you do 16 to the 1/2 power, you get 4. What are we actually doing when we take something to the 1/2 power? What is that the same as? Or have we seen that before? Square root. Yeah. This is the exact same thing as the square root of 4, the square root of 9, and the square root of 16. And that's what we want you to connect with this Warmate, is that the way we can write square roots can also be represented as a fractional exponent. All right? And hopefully along the same lines, when you did 8 to the 1/3, you got 2. When I did 27 to the 1/3, I got 3. And 64 to the 1/3 is 4. So what is that the same as? What else could I do to 8 to turn 8 into a 2? What is that? I thought? Cube root. Okay. If I take the cube root of 8, which you might not know where that is on your calculator, I'll show you, or the cube root of 27, or the cube root of 64, you'll get those same answers. I want to make a small connection here. See this third root, or the cube root? Where does that appear? It's like dividing by the 3. The divide by 3 in the exponent is what turns that into a cube root. And what we don't do, or we don't need to, is there's actually an index number of a 2 right here when we do the square root. And that 2, see how it's divide by 2 in the exponent? That divide by 2 is the same thing as the square root. So there's a pattern that I want you guys to notice. Grayson, do you want to put that away? You don't need that. So let's look at right here. If I have 25 to the 1/2 power without a calculator, hopefully your brain is thinking, okay, this divide by 2 is the same as taking the square root of 25, which is 5. The square roots we're pretty good at. Cube roots might be a little bit more of a challenge, but hopefully you can see, oh, I've got 125 to the 1/3 power. If I rewrite that as a cube root, you might be able to do this. Either you know the answer in your head, or if you really want to, with cube roots, you can play the divide by game, and notice I've got 5, 5, 5. I've got 5 times itself 3 times. But what about if there's more than a 1/2 or 1/3? And this is where it gets a little tough. I was going to see if you can get these in your calculator, but to do these without a calculator takes some practice. So my hopes are you were able to get this answer in your calculator, but let me show you where it comes from. We're going to actually take the rule that we saw with the square roots, and see how I have a divide by 2 here? I'm going to change this into a divide by 2. So I'm going to turn the 4 divided by 2 is the same as the square root of 2. So that blue highlighted part is the exact same thing as the square root of 4. And notice how that exponent of 3 gets pushed to the outside? We're going to deal with that later, and now we deal with order of operations. So let's do the inside part first. We know that the square root of 4 is 2, and that becomes a friendly number. And now 2 to the 3rd power, 2 times 2 times 2 is 8. Let's look at basically the exact same setup, but now it's 9. So this divide by 2 here is going to really turn into the square root of 9. Notice the numerator 3 is just going to be pulled to the outside. And you don't have to put this little red 2 here. That's an index number. If it wasn't a divide by 2, then you would have to. But squared, we don't have to write it. But now, I know that the square root of 9 is 3. And then we know 3 to the third power is 27. But what if I flip it around for the next problem? Now it's 27 to the 2/3 power. So I'm going to take a look at this and say, all right, there's a divide by 3. That's like a cube root. So the divide by 3, we're going to deal with that first. And that'll be the cube root of 27, which we already know, raised to the, not the third power. Now it's the second power because 2 is up top in the numerator. And then I know that the cube root of 27 is 3. If you don't know that, you could split it up. And we play that factor game. 3 times 3 times 3 is 27. So 3 to the third power is the same as 27. And the cube and the third would be that. But now I have 3 squared, which is 9. So I'd like you to try these last two without a calculator and see how far you can get. Patterns a little bit on your own. So, with that being said, this material does come up later on throughout pre-calculus, calculus, and it's a really big concept that we want you to kind of have mastered. So the key that I think of is, let's look at the divide by 2. Well, that divide by 2 is the same as the square root. And then the numerator of 3 is just going to be pushed to the outside. Now there's a property of exponents here that we could get into further as to why that works, but I think this is just a quick pattern. And then we take the square root of 100, we get 10. And then it tells me to do 10 times 10 times 10, which is 1,000. Right, the next one. Now I have a numerator of 2, so that's going to be pulled out. And the divide by 3 is the cube root of 64. And we know that the cube root of 64 is 4. And then 4 squared is 60. Okay. For the rest of the school year, I think it's important for you guys to understand kind of where we're headed and what's left over. So this is our trimester 3 calendar. It's kind of our planning calendar, so it doesn't mean a ton to you guys. Last Friday, you just had a test on polynomials. I have not had a chance to grade that yet. My goal is to get that graded either today or tomorrow. When I looked last night at like 10 o'clock, there was 6 or 7 people that did not take that yet. That should be a top priority, getting that test taken today, hopefully in the afternoon session. You have a 90-minute time limit on it, but I don't think it takes that long. I think it probably takes about 45 minutes. So get that done if you haven't done it. So where are we at? We are starting chapter 6 now today. This is Monday, Tuesday. And officially, that's 6.1 and 6.6 of our textbook. And then tonight you have a Delta Math homework. Tomorrow we're going to cover something called inverse and composition of functions. And then we have a quiz on Friday. I shouldn't say tomorrow. This will be Wednesday for you guys. Quiz on Friday. And then when we scroll down, we've got some graphing. We're going to do a Desmos activity and graphing with square root and cube root functions. Then we have a mini test. This isn't going to be as big as most tests because we're only spending just a couple of quick sections on this. And then we've got the last unit, is chapter 8. And we're going to cover 4 days on chapter 8 with a quiz and a test. And then we have the last week of school, of like regular school, and then we have finals week. So if you look at that, we're currently right here. Oops, I don't like that. So we've got, if you count this week, here's 1, 2, 3, 4, 5 weeks. Now my grade book is going to be closed most likely on the Wednesday of this day. It might even be Friday. I got to double check with Ms. Hires. But my grade book is going to close for any late work. And then we have just a little final wrap-up activity at the end of the try. So we don't have a lot of time left. I started counting, I forgot, 2, 4, 6 full, not even full weeks, because the last week we don't have Monday and we don't have Friday. So less than 6 weeks of school left. And some of us are at a point where our grade needs to really improve. And that just means you got to get some things turned in and done before the due dates. All right. So we are jumping into chapter 6, and it's going to sound odd, but we're actually teaching the last section first of our, if you were to look back in your textbook, because this is all about solving. And we know how to solve. We know how to solve for x. The only difference is now they're going to have radicals in there. And the word radicals really is just like a square root, a cube root, or an exponent. And that's what the warm-up was all about, was to get you used to those exponent pieces. Now, we're going to just show you the steps here. I would definitely write these down. When you were solving before, we used PEMDAS, right? We used PEMDAS backwards. So you tried to isolate the x value. Well, this time, instead of isolating just the x, we're going to isolate the radical or the power. And when we say radical, we mean something like a square root, or maybe a cube root. But as we just saw in the warm-up today, it could be the same as something like to the 1/2 power, right? That's the same as the square root. Or it could be something the same as the cube root. Or it could be something really crazy, like x to the 4/7. We're going to learn how to deal with any exponential fraction. I should say exponent in the fraction. So the big key is to isolate. When we say isolate, that means get that term all by itself using whatever math properties we need to. Then what we're going to do is we're going to change all of the roots, which are radicals. If it looks like a radical, we're going to change it into a fractional exponent. And that's what the warm-up did. Right? If it was a square root, we could rewrite it as the 1/2 power. And then this is really the key part to solving right here is how do we undo one of these exponents? We raise each side to the reciprocal power. That's the part that might be new for you. And once you undo the power, all that's left is algebra. Now we say all that's left, but that could mean solving a polynomial expression using any of the methods we just learned. So it could be the quadratic formula. It could be factoring. It could be factoring by grouping. It could be doing the box with the circle in it method. Any of those methods that we've learned up to this point are fair game. And then one of the most important things that often gets overlooked is checking your answers. We have something called extraneous solutions that really have not come up yet this year. When we see one appear, we're going to define it as an extraneous solution, but I'm going to let that happen organically. So this seems like a lot of steps. To be honest, once we get through a bunch of these problems, you're going to be doing this naturally. It's a natural progression on how you've solved things up to this point. Really, there's three important things. Isolate the radical, raise each item to the reciprocal power, and then check your answers. If you can remember those three things, that's not too bad. So, here's our first problem that has a radical in it. Now notice when we say radical, we're talking about the cube root. A lot of times, there's more than one thing going on under that cube root. So we want to really think about, when we say isolate the radical, what are we talking about? So I'll give you a second to finish writing these down, and then go ahead and write this problem right here down, and we'll go over this. So when we say isolate means to get by itself. So I want this whole piece. Notice the x minus 3 is together with it. That x minus 3 is protected. I cannot do anything with the x minus 3 until I get rid of the radical. But right now, there's something in the way. The plus 2 is in our way. You do not have to show that step of minusing 2 to both sides, but that's the first step that you need to do. And then we isolated the cube root. All right, so the cube root is all by itself. We're going to do one extra step. And you might think this is a little bit of extra work, because technically I'm thinking a lot of you may already know, how do I get rid of a cube root? What's going to undo a cube root? Or what if it was a square root? Maybe what would undo a square root? Squaring it, right? You could square both sides. Technically, you could cube both sides, but I want to make a connection to this step up here that says change all roots to fractional exponents. So the cube root is the same as the 1/3 power. All right, we saw that in the warm-up today. So now, how do I get rid of the 1/3 power? We're going to undo current exponents by raising each side to the reciprocal power. So right now it's the 1/3 power. We're going to raise it to the 3/1 power. But if I do it to one side, I have to do it to the other. And then we're going to look at why this works. Okay? When we have a power to a power, you might not want to write this, but if I have 1/3 times 3/1, that turns into 3/3, which is just 1. So technically, people say the exponents cancel out on the left side. They cancel out because they turn into a 1, which means all that's left over is the x minus 3. I'm going to erase this just so it doesn't look more confusing. But then what do we have here? We've got 2 to the 3rd power, and we know that 2 to the 3rd power is 8. And then it's a really quick algebra problem now. Add 3, and I get x equals 11. Now, we're not done. And this is the part where some of my students that aren't focused on the details, you get in big trouble. Because we have to check to see that this answer actually truly works and exists. We have to check it into the original problem. Okay, so what we're going to do is just rewrite the original problem, but instead of x, we're going to put the answer. And then we just have to simplify it using order of operations. And you don't have to show every step here. If you could do this in your head, perfect. Right? If you want to grab your calculator and check it, that's fine. But what I would do is this. 11 minus 3 is 8. The cube root of 8 is 2. 2 plus 2 is 4. Does the left side equal the right side? The left side turned into 4, the right side turned into 4. So that makes me happy. Now keep in mind, this is not my answer, right? My answer is 11. But when I plug it in, the expression on the left is equal to the expression on the right. Alright, well, I still want to get used to this turning it into a fractional exponent piece. I know it's a little bit weird. To be honest, if you were doing this problem, you would probably skip that extra step, but you'll see in a little bit why we're making that extra step happen today. So let's look at this problem here. Our goal is to isolate the radical. So that square root, we have to move everything else over to the other side. So the minus 1 has to move over. Now I'm going to save one little step. We know that the square root is the same as the 1/2 power, so we can just kind of write that in instead of changing it. If you're not super comfortable with that, maybe the coloring will help. That square root turns into the 1/2 power. So look at that inside. The 7x plus 95 is protected. We can't do anything with that until we remove the exponent of 1/2. And the only way we can get rid of the 1/2 is to raise it to the reciprocal power. Remember, reciprocal is taking that fraction and flipping it upside down. So what did we technically do? We squared both sides, right? And that's what you would do normally. But why does squaring and the square root reduce out? Because these two exponents, the 1/2 and the 2/1, I'm going to erase this, so don't write that. What do they turn into? Turns into 2/2/1, so those exponents go away. And you're left with 7x plus 95 equals, now this is kind of poorly written, that's sloppy. This is really just 9 squared, right? I don't have to put 2/1 because that 1 doesn't do anything, but 9 squared is 81. And then we're just going to do some quick algebra and solve. So now we just got to check, right? And you can do this in your head or you can do it on the calculator. I'll show you what I would need to see in terms of showing work that you checked it. Because a lot of times kids say, oh, I checked it in my calculator, and they didn't. And then you'll see in a little bit why that's a big problem. But what I would need to see for you to check is you could do all this in your calculator here. Okay? You could even do this. And negative 14 plus 95 is 81. Square root of 81 is 9. If you truly did it all in your calculator, I would just need to see this right here. That tells me that you proved or you've shown that the left side is equal to the right side. And that tells me that x minus 2 is an answer that truly works. Okay. Both of these problems we just did here are about as easy as they're going to get today. And the reason why I showed you these is hopefully it was just the first step of isolating and changing to the reciprocal power, and everything else worked fine. But it gets harder and it gets trickier. So don't think you've mastered it from these two examples, because it changes. And that's really, we're just going to do a bunch of examples today that are all slightly different, but you're going to realize it's almost the same pattern. This might be the one that really tricks kids. Because we have a radical, so we get a cube root, and we have a fourth power. So we're going to do something with properties of exponents that makes this just a little easier. But first, we have to isolate. So anything that has a cube root or a fourth power, you can think of all of this as being grouped together. I need to isolate that. So what I have to do is subtract the 44 to both sides. We'll get 256. Now, I'm not saying that the way that I'm teaching you it right now is the only way to do it. There are multiple ways to solve some of these problems. But let's look at this part right here. The third root. Remember how that is the same thing as raising it to the 1/3 power? That's what the warm-up told us. If we had a third root, it's the same thing as the 1/3 power. So I'm just going to add one extra step in here today. So hopefully you can see how that 1/3 power turned into, or excuse me, the third root turned into the 1/3 power. Okay, and now, if I have a power to a power, this 4/1 is going to be times by the 1/3. So instead of doing this as two different powers, we're going to combine this together, and the 4 is on top, and the divide by 3 is on bottom. Any questions on that? A quick way to do it is if you see the third root, you're going to take whatever exponent is there and divide it by that power. All right. Now, we turned it into the fractional exponent, and it's isolated. So how am I going to get rid of a 4/3 power? We're going to raise both sides to the reciprocal power. So instead of 4/3, we're going to raise both sides to the 3/4 power. And look at what happens on the left side. 4/3 times 3/4 is 12/12, which is 1. So we don't have to write the first power up there. That just leaves it as an apex. And then at this point, if you really wanted to, you could break this down. But right now, I just grabbed my calculator. And I haven't shown you this yet, so I'll just show you how to do it on my calculator. But if you know how, go ahead. I thought I had my calculator up. Hold on. So I want to take 256 to the 3/4 power. So 256, and then that's where this little caret symbol comes in. And then I always put parentheses anytime I'm dealing with a fraction. That's kind of out of habit. It would be fine if you didn't, but it's important to know that that's where that came from. And then you can see our answer is 64. You could have broken this down by hand as well. You could have taken the, don't write this, but you could have taken the 256 to the 1/4 power, which I think is 4, and then apply the third power to that, and that's where the 64 came in. But as we saw, that's what the answer gave us anyway. Now, we're not done, right? Because our goal is to find x, and once we got rid of the exponent, we can divide by 8, and we get x equals 8. All right, but as we had said, we're not done, right? You got to take the original problem, and now we got to check. And let me show you how I would do this in my calculator. All right, I'm going to take 8 and plug it in. So if I plug 8 in here, I'd have 8 times 8, which is 64. So then I'm going to do 64 to the 4th power. I'll make this bigger. So 64 to the 4th power, hit enter. That's a big number, right? No way you could do this without a calculator. But then I have to take the cube root, and this is the part you might not remember where the cube root is. So you hit the math button, and look at the option down here. Option 4 is the 3rd root. So math, option 4, and then you can either go second answer, and that'll just take this big number and plug it in, or you could just take and type that in. Either way, when I do 64 to the 4th power and then take the cube root, I get 256. And then what else did they have me do? This whole piece is 256. 256 plus 300, or excuse me, plus 44 is 300. So plus 44. And since I did that in my calculator, how could I tell the person reading my work that I showed my work? Here's what I would do. Just write the word check, and you show that 300 equals 300, and you prove that x equals 8 is the answer. Okay? All right, why don't you guys try this one? What would we do here? Well, first thing is if I have everything isolated, the 5x minus 19 is protected by the exponent. So I have to get rid of that exponent first by raising both sides to the 6/5 power. And when I do that, you can kind of picture the 5/6 and the 6/5. That turns into 30 over 30, which is 1. So the left side turns into just 5x minus 19. And then I'm going to go to my calculator here. I'm going to do 32 to the 6/5 power. So 32 power, parentheses, 6/5. And you get a 64. Okay? Nothing crazy there. We could have probably broke that one and done that by hand. But that turns into 64. And then I have to add 19 and divide by 5. Now, I know right away that 5 doesn't go into 83, so leave it. It's okay to have a fractional exponent, or answer. But now I have to check this. And this is where I would just recommend using your calculator. So I've got 83/5. I have to do the inside part first. So I'm going to do 83/5 times 5 and then subtract 19. So let's go, let me figure this out. 5 times, and then I'm going to do parentheses, 83 divided by 5. Notice here a times by 5 and a divide by 5. That's going to go away and just give me 83. And then 83, was it minus 19? Gives me 64. And then we have to take that answer. So all I'm going to do is just hit the up arrow, the caret, and it's going to say you want your answer to what power? And now it was 5/6 power. And if we did everything right, we should get the left side being 32 and the right side is 32. So if I did all that in my calculator, I just need to tell the person reading that 32 is equal to 32, and that means I'm happy that that answer works. So notice how I didn't grab a decimal. Decimals usually involve some type of rounding, and when you round in a process like this, you're not going to get a perfect 32 equals 32. So that's why I turn it into a fraction when you can. Okay, so we're going to skip these two. We don't need to do those. I do think we should do these. All right, this one is a little bit interesting now. We haven't seen one exactly like this because it requires more than one step to isolate. So when we say isolate, we want to get rid of everything that is not inside of the radical. So anything inside those green parentheses has to move over to the other side first. And you have to follow correct solving procedures. So we always add or subtract first. So I'm going to move that plus 12 over. And kind of at the same time, instead of the 1/3, I'm going to x the cube root. I'm going to rewrite it as x to the 1/3, just to save me one extra step. But now I have to get rid of that -5. So we're going to divide by -5. And again, you don't have to show these red steps. It's just me showing you guys what would happen. Negative x to the 1/3 equals 4. Well, now we have the fractional exponent. By the way, just raising it to the 3rd power works, because that's the same as 3/1. So you don't have to put the 1 underneath. And 4 times 4 is 16. 16 times 4 is 64. Okay? Now, this is an interesting problem as well, because a lot of times kids get confused when it's a negative. How can my answer equal a -8? Well, the math should work out. I'm going to let you guys check in your calculator, but it should work. So just do that really quick. Remember to do the cube root of 64 first. Alright, I'm going to show you if you want to see how I would do it. This is what I would do. I would do math, option 4, that's the cube root, and then I take 64. I know that's 4. I'd take that answer and times it by -5. And then it said add 12. And you can see I get negative 8 for the left side, which is the same as the right side. Okay. Definitely write this one down. This one is where we kind of get into some interesting results. So far, every single answer has worked. Right? Whatever answer we got, we plugged it in. You're thinking, why do I need to check? All right. So we've got the square root of 44 minus 2x plus 10. Well, we have to isolate whatever is under the root. So I can move the 10 over. And kind of in that same step, remember that square root is the same as the 1/2 power. So I'm going to just rewrite that as 44 minus 2x to the 1/2. And then I have x minus 10. It doesn't help me a ton. However, it now allows me to get rid of this 1/2 power. How do I get rid of the 1/2 power? Raising it to the reciprocal power, which, again, 2 over 1 is the same as 2. Uh-oh. X minus 10 squared. You may have to come over here and do some side work. Unless, if you can do this in your head, but remember what it means to be squared? It means take x minus 10 times x minus 10. And we have to FOIL, or you can use the box method, but we need to multiply these out. So I get x squared minus 10x minus 10x plus 100. So this is where our chapter 4 work comes back into play. We always keep using the skills we've learned. And then I know that the two middle terms are going to add up to negative 1x. So now we go right back to chapter 4, chapter 5. Now I have to think of how do I solve a problem like this? Well, what we need to do is keep everything on one side. And I always like to keep the squared value positive. So I'm going to leave the blue side, and I'm going to move a 44 over. And then I'm going to also add a 2x in the same step. What that does is it leaves a 0 on the left side. And then we get x squared minus 18x plus 56. And then we have to think about, now what? What options do I have? I could do the quadratic formula. I could do the box with the circle in it, but this one actually is a little bit friendlier. What times what gives me 56, but adds up to give me negative 18? You might grab your calculator right now. Do 56 divided by, try it divided by 2. Are those 18 units away? No. What about 4? 56 is 4 times 14. But what if they're both negative? So if you don't like this, you could do the box with the circle in it. But we factored that. And then as we learned before, our goal is to solve. So find the zeros by setting each one of those equal to 0. Then we have to check. Right? We have two answers. I need to check. And you know that if you check x equals 4, this is where we plug in a 4 on each side. So maybe I'm going to show a little more work on this one, just so you guys can see it. So then we get 44 minus 8, which is 36, I believe. Square root of 36 is 6. 6 plus 10 is 16. Does that equal 4? No, and this is the first time that we saw this. So what are we going to do? We're going to cross that off. It was a solution that appeared mathematically, but when we check it, it produces a false result. So this is called an extraneous solution, which is not part of our actual answer set, because when it's checked, it produces a false result. And that was that special piece that you have to check for extraneous solutions. All right, well, if 4 doesn't work, what does that tell us about 14? Does 14 work? I don't know. Let's check. We're going to take that exact same equation, plug 14 into each side, and then simplify. And again, you can do all this in your calculator if you want. 1p. So after kind of all that, I know I did that pretty quick, but you can see when you plug it in, you get the square root of 16, which is 4. 4 plus 4 is 14. 14 equals 14. So that tells me I have one real solution and one extraneous solution. Now, you can have cases where you'll have two real answers. You can have cases where one is extraneous. You can have cases where both are extraneous. So that's why it's important to check every answer that you get. All right, I want to make sure that we finish with a really good problem. So we're gonna skip this problem right here. The reason why I had this one, notice it's basically the exact same thing. This one has two answers, but both of them are extraneous. They both just don't work. And I wanted to do that, but we're running out of time, so there's better problems to get to. And then we're going to do this one. I don't want you to do this one right here. But let me just show you quickly how this one on the left-hand side will be done. So, as I said before, remember when we changed things to the 1/2 power? And that's just doing a little extra. What you could do here is just square both sides. Because doesn't a square and a square root reduce each other out? And when that happens, notice the radicals are gone, and you just do regular algebra. I'm going to subtract an x, I'll add the 9, and I get x equals 1. So sometimes kids get really confused. They see a radical on both sides. They're both isolated. There's nothing else going on outside of them. You can just get rid of that radical, and it'll quickly make that problem much easier. All right, let's write this one, because this one is not friendly. And this is, we got to go fairly quick. All right, what happens when I have two radicals? I have two radicals in this example, but they both reduced out. Well, here, I got an extra 2 that isn't in there. And if I say isolate the radical, if I try to move anything over, it's still not isolated. So what we're going to do here is we're just going to take the fact that, you know what, this radical is already isolated on the left-hand side. And we're going to rewrite it by getting rid of that radical. So I'm going to square both sides. All right, when I square, the square and the square root go away. So I'm left with a pretty friendly x plus 2. What's not friendly is the right side. So I got to do some side work over here. And I have to take the meaning of what it means to square. So I'm going to take 2 minus the square root of x and multiply it by itself, which seems pretty decent to start. 2 times 2 is 4. I get negative 2 square roots of x. And then I also get another negative 2 square roots of x. And then I get a negative times a negative, so it'll be positive. And this is where some students get a little confused. If I have the square root of x times itself, right? Isn't this the square root times the square root? That's the same as writing it squared. Well, the square root and the squared go away, so that box just turns into x. And then I've got my like terms in the middle that can be added together. So you could do that in your head if you really get used to it. But what I would recommend doing is a little bit of side work so it looks like this. Okay, and then notice a negative 2 square root of x plus a negative 2 square root of x, that turns into the middle term, negative 4 square root of x. And that doesn't look like it's super helpful, but notice, I got rid of one of the radicals. I only have one left. So now, I'm going to do this really quick because we got like 30 seconds. Subtract an x, and they go away. Subtract a 4, and I get negative 2 minus 4 times the square root of x. And then I'll divide. I apologize for timing here, guys. So all that gets the other square root by itself, and then if I just square both sides, when I square 1/2, I get 1/4 equals x. Okay, homework tonight is delta math. If you have more questions, you can come back at 12:15, and we can go over more of this if you'd like. All right, have a good day, everybody. Adios. That's the 9 minutes break yet. So we had a busy hour.
Do we have a busy hour today?
Was that our last unit? Yeah, but now it's review.
review. Oh, wow. Review sheets?
Yeah, technically. Some of it, a lot of it's digitally. But
That's all I have left.
Desks are wet. Why is this not working?